Hello, in this video I want to talk about consumers constrained optimization, the choice that consumers make in order to maximize happiness. In order to talk about this, we have to first define happiness. And in economics, as you know, we use utility to measure a person's happiness. So when we do this mathematically, we have to set up a utility function. And it's going to be a function of two goods, say good A and good B. And we have to give that some functional form, and we actually do the solution. So let's just say that utility is just A times B. All right. This is a constrained choice because otherwise, of course, consumers would just decide to consume an infinite amount of A and B. But usually we think of consumers being constrained by the price of the good A, the price of good B, and their income level. So basically what we have to make sure is that what consumers spend on good A and what they spend on good B cannot be greater than their income. And of course, what they spend on good A is going to be PA times A, and what they spend on good B will be PB times B. If you add those two consumptions, you're going to have your income level. So what we're trying to do here now is just maximize our consumer's utility equals to A, B, and subject to the constraint that the money spent on good A and the money spent on good B has to be less than or equal to the income. All right, just to make this more concrete, let's just suppose that the price of good A was, I don't know, say 2, and the price of good B is, say, 4, and the income level of this consumer is, say, 100. And the way I want to solve this is just using the substitution method, which means I'm going to solve for B from the income constraint, and then I'm going to substitute that into the utility function in order to maximize it with respect to good A. So in order to just solve this one, I'm just going to put B by itself on one side of the equality sign, and then we have that B equals 25 minus 0.5A. All right, so if I give myself a little bit more space here, I'm going to plug that into my utility function. So we remember utility was equal to A times B, but B now is 25 minus 0.5A. And if I just multiply that through to just make it easier when we're going to take the derivative here, so I have 25A minus 0.5A squared. All right. So again, we want to maximize this, so we're going to try to maximize this one. So the way we do that, we take the derivative of u with respect to A. And if I just go ahead and do that, that's going to be 25 minus, and you know, our exponent is just going to come down. So 2 times 0.5 is just 1 times A equals 0. Obviously here we have that A equals 25. And then we use our expression for B to figure out what B will be equal to, which is 25 minus 0.5 times A, where A is equal to 25, and therefore B equals 12.5. All right, so these are our values of A and B that will maximize our utility given our utility function, which again was equal to A times B, and given our income constraint, which is that 2A plus 4B equals 100. All right, thank you very much.